Hello and welcome to TADSummit Asia. Today I'm going to be presenting on a WebRTC status review across Asia. Now the review will be general, so it works for any region, but at the end I'm going to focus on recommendations in terms of what you should do with WebRTC, and that will be, I'll be making 6 recommendations, and that's going to be more based on my experiences working with companies in Asia around RTC, real-time communications. So in this presentation, I want to start by taking you back. So we're going to time travel to 2013, April 22nd to be exact. And on that date, I was giving a workshop on WebRTC in Barcelona, just before the IMS World Conference. And with me presenting was Jose de Castro. Back then, he was the CTO for Quayle Labs. They changed the name to Tropo. They got bought by Cisco. And today, he works for Twilio. And you're going to see a lot of names as I run through what we were doing in this workshop in 2013 that are quite common in the CPaaS and WebRTC world. In the workshop, we provided both a deep technical and business analysis to help people understand what was going on with WebRTC. We also gave a view of where it's going to go over the next couple of years. And then we had some really interesting demonstrations. I'm going to briefly highlight some of them that we gave. So I gave the introduction, initial market review. We then did a standardization deep dive, and standards are very important to WebRTC. We then did a technology deep dive. We then ran through what it means to telcos and then to enterprises. Now, on the demos, let me run through some of those demos, as you're going to recognize quite a few of the names. Zingaya, also known as Vox Implant. They hadn't raised any cash back then. We had a demo from them. Quayle Labs gave Amici, which is their IMS WebRTC application server. They showed the CPaaS, which was called Tropo. And they showed Phono, which was their WebRTC API that AT&T briefly trialed. And they gave some interesting demos covering identity. We had Telestacks. They showed their WebRTC SDK, as well as some services built on it. Solomaze, they were bought by Converse and JM Jose, one of the founders of Solomaze, is still very active in WebRTC today. Cobis, and I'll be coming back to them later. They gave a demonstration of their coffee sip, and we even had some of the big guys. Huawei was showing a WebRTC RCS insurance application demo. Again, it's interesting to compare. We were showing a demo with both those technologies, and WebRTC is almost everywhere. RCS, well, yeah. Drum was showing, NetDev was showing Drum, the video conferencing service, which of course is a very popular use case for WebRTC. Bistri was showing their social video, and then Apidaze was showing their WebRTC SDK. And Apidaze was bought by VoIP Innovations. VoIP Innovations was bought by Sangoma. Sangoma are one of the sponsors of TADSummit Asia. And back then in 2013, this was our Bible. And it was written by Alan Johnston and Dan Burnett. So let me run through some of the initial market review I gave. Now, as I do this, I will be doing a little bit of time travel. So be ready for, it's going to get a little crazy, but we are going to travel in time between 2013 and today as we compare where WebRTC was and where it is today. So it's open, nothing proprietary. The 2 standards bodies driving this are W3C and the IETF. It's no plugins, so no Flash, no Java, no Silverlight, and supporting multiple platforms and devices. Really, it's real-time stuff in your browser with no plugins. Now this, of course, has proven to be one of the dominant use cases, video conferencing. Today with COVID-19, everybody is using this, and WebRTC underlies most of the services that people are using. Gaming, is still growing. It's still, it's not there yet. We have, of course, Google Stadia, Agora.io. When they raised their 70 million, they were highlighting some of the work they were doing in supporting games development. M2M and telematics less so. There's a certain amount of sort of processors and stack you need to use WebRTC, and really the devices tend to be sort of extremely low power or very cost sensitive, even in cars. But surveillance and monitoring, we have seen quite a few applications there. You're just using a camera with a very cheap Android, basically phone in it. And I've seen some very interesting WebRTC applications there. Again, because the endpoint has a little bit more cost to it. But of course, it has delivered on lots and lots and lots of devices. WebRTC has really delivered on that. Embedding communications everywhere. So whenever there's a beautiful vision, there's always reality. Now, of course, part of that is Google. Back in 2013, Google had a dominant position. And I'm going to show you how it's got an even more dominant position today. And it basically owns and is constantly sort of messing around with WebRTC. And that creates, it's tough unless you're on basically in bed with Google. Microsoft was trying to position in this game. You'll see, it's less so today. It had its own go at trying to create a version of WebRTC, but I'll come back to that in a couple of slides. Now, here's the warning. We're going to be time traveling now. So get ready. We're going to go back and forth between 2020 and 2013. I'm going to warn you when we travel, but your head will be spinning a little. So here we go, traveling back to 2020. Now today, we still have the W3C and the IETF. You've got, of course, within W3C, it's the browser guys. They control. IETF is consensus oriented, so everybody can basically have a say. And that means it's more consensus oriented, so the browser vendors can't dominate. So that creates part of the challenge, where you've got this body, consensus, so Cisco can have a greater say, while in W3C, basically Google, has most of the control there. It oversimplifies the politics, but this has been part of the challenge in WebRTC. Okay, we're going back to 2013 again. Back then, it was the telco protocols for voice and video and the internet. Of course, the ITU were like, oh, these internet guys, they can't possibly do anything relevant in media. We know media. Well, time has proven them wrong. The internet won. It's Opus. I remember a presentation actually in 2014 where Deutsche Telekom was showing how well Opus could run over LTE. So it's game over. Those have won. Now coming back to today, it's a different battle. It's no longer the telcos on in it. They're irrelevant. It's now between AV1 and VP9. AV1 is the new video codec. VP9 is, well, a new video codec, but has some issues. There's a bit of a battle going on between them. In the limit, it's going to be decided by which has more or broader hardware support, because you need hardware support for these to run. Otherwise, you find your battery getting gobbled up in next to no time. Time traveling back to 2013 again. I said your head was going to be spinning. WebRTC was not everywhere. Well, I'm just showing you whether the API had been implemented in the browser. I'm not even showing you interoperability here. Again, it gives you a feel for, even back then, it was slowly coming into browsers. Now, as we look today, this isn't showing whether it's implemented. They've all got a version. It's showing what interoperability is. And this is, I got the website up there, so you can basically have a look at sort of interoperability, the tests that are being placed between the different browsers. And you can see it's still not completely interoperable. So there's still hiccups here today in 2020. Going back to 2013 again. Internet Explorer. So Microsoft said, look, we're everywhere in the enterprise. If you want to consider WebRTC an enterprise, you have to follow our basically view of the world. Well, let's time travel. Today, 7 years later, I think this is quite telling. Well, you can see Microsoft are pretty irrelevant today. It's Chrome and it's mobile. And mobile back in 2013 was more complex. This shows all the different browsers, and you could have native browsers that was natively in the OS, second browsers, third-party SDKs. It was a little bit complex and unclear. Well, that's now today, as we try and travel back, it's game over. It's Android and Apple. That's it. You know, it's as simple as that. That's part of the reason why now Google has such a dominant position. So are you feeling sick yet? That was a lot of time travel. So hopefully you're not suffering motion sickness. We're nearly done on the time travel. We're back in 2013 again. Let me just do a couple more slides and then we'll stay firmly planted in 2020. Okay? Back then, 2013, there was no approval process. There isn't today. And to be honest with you, in the limit, it's which browser gives you the better experience. I use Firefox, generally, if it's not a Google app or a Google WebRTC-based service, simply because Firefox has, I mean, they implement the standards and it just damn well works. It's reliable. If it's a Google app, it's using, you know, like Duo or whatever, I'll use Chrome because it just works better. So, you know, you use multiple browsers depending on the service that you're using. And yeah, look, there's Microsoft in the background. Now, WebRTC was in 2013 a car without wheels because there was no signaling, and that was intentional. That was by design. You chose your own signaling, and that's not actually proven to be that bad, and it's still true today. So that's it. That's what some of the slides I presented, and hopefully gives you a feel for, you know, some of the things that have and haven't changed on WebRTC. Now let's stay firmly in 2020 from now on and reflect on some of what I was presenting back there. So, but Alan, in the workshop, you showed us, you know, basically demos running on multiple browsers. It seemed pretty baked. And in November 2017, the WebRTC 1 specification was transitioned from working draft to candidate recommendation. And so it's like 2.5 years ago. Why hasn't it moved to proposed recommendation and then, you know, basically, final endorsement and a W3C recommendation? What's going on? Well, WebRTC is sort of trapped in an interoperability Pareto jail. That is, 5% of the features are taking 95% of the time to complete because, you know, and here's the link in the charter, it must be interoperable. So to advance to PR, you know, you need 2 independent implementations that must be bidirectionally interoperable. So they're the criteria. Now, to be honest, WebRTC 1.0 only matters to a niche of like governments or bodies that require standards for purchasing. However, just for a matter of principle, guys, if you're going to use these standards bodies, get a damn 1.0 spec out. So I'd say it's more a matter of pride. Most people are just going, yeah, it is what it is. We've got so many other headaches to deal with. For example, I show here, again, a recent from May 4th, showing, again, some of the interoperability issues. This is for basic simulcast. So here, it's just showing, the server-side guys have to work hard at interoperability, while browsers keep changing quite often. It really is a game of whack-a-mole on interop. The SFU developers, so this SFU is Selective Forwarding Unit, and this is sort of part of like the video conferencing stuff. It's, think of it as the WebRTC uber geeks. They're always chasing after the latest browser or libWebRTC version, and sometimes finding changes only because stuff stops working. libWebRTC, it's CC++ library, 10+ years old. basically sort of owned by Google. And of course, they have lots of smart engineers that think they're smarter than every other software engineer that's ever existed and keep changing stuff in there. Even though, the functionality is notionally the same, they've changed the code and stuff happens. So when will WebRTC 1.0 be released from Pareto JR? Well, maybe the second half of next year. Should definitely be by 2022. I mean, really, it's starting to get a little embarrassing in terms of standards when they can't get something out by then. So anyway, back to the buts. Why are WebRTC companies like Vidyo being sold at a valuation less than revenue? The recent Callstats.io acquisition was considered to contribute negligible revenue. If WebRTC is the future of communications, why are some of these companies, going at relatively cheap? Well, first of all, it's acquihire. And I'll explain why it's a constant recycling on the acquihire. You've got companies like Google that are just taking talent off the market, bring them in, assign them to other non-WebRTC related projects, and then they'll become basically a little bit stale on WebRTC. So you can keep the skills here rare. That's part of the game that's being played. And the other is what I call endurance hunting. Now, this is this is a very important sort of aspect of human hunting. And the fact that we can run for a ridiculously long amount of time. We can walk all day, and as long as we got some water, we're still refreshed. We can chase down far faster prey just by constantly following them. And this is sort of the thinking behind what's happening in WebRTC. So companies like Cisco, RingCentral, they're in this game. And WebRTC is the future of communications. It's their future. And you have to be in it to win it. So part of what's happening is they're all in here for the long run, and they're all using acquihire to basically remove potential competitive threats to the long run game. So that's an important aspect to understand why you're seeing some acquisitions at relatively low valuations. Also, again, but it all seems so simple back then. Why is WebRTC so complex? Well, again, here's some of the specs. Real-time communications is complex. Let's not kid ourselves. And then, real-time communications over the mess that is the internet is hideously complex. And as we've gone through and battle tested a lot of the protocols and architecture, we've really learned a lot. And as a result, the standards have got complex. And just to sort of provide a little bit more context around that, the original idea was not to invent everything within WebRTC. It was to take stuff that's already out there and to reuse it. So like SDP, DTLS, RTP, ICE. So yeah, and that made a lot of sense. It's like, let's try to, reuse whatever is available. But it did lead to a very complex protocol layer and architecture. Now, unfortunately, some of that reuse was of stuff that was relatively immature. And WebRTC did the battle testing, and that required improvements, revisions, and a fair bit of work to get it working. Well, I know this is controversial. Some people love SDP, some people hate it. There are issues, let's put it like that, with SDP. Now, WebRTC required other standards bodies to develop some of the spec. And of course, as I mentioned, W3C, the browser guys sort of run it. So once stuff was into the IETF, then those that had no control all of a sudden did, and it became a political bun fight. Also, the specs weren't closed fast enough. There were too many chefs in the kitchen, so it took on too many features. And what it's done is it's made components like SFUs brittle, hard to debug and test, and the browsers are even worse. As I mentioned, you only discover something is changed because part of your service isn't working, and it's getting more complex. Let's not pretend that it's going to be magically simpler in 1, 2, 5 years time. We've got RIPT, which is sort of like an NNI network interface for SIP to basically make it sort of easier for serverless implementations. A new protocol there with Quick, the AV1 codec I mentioned. And then there's stuff that's not directly within the WebRTC remit, but it's very important. Will Apple and Google, for example, agree on a common API? So, a platform can, set that up on Chrome or Safari or native iOS. Now this isn't a WebRTC issue, but it does need to be resolved if we're to deliver on the vision. So as hopefully, reflected some of the complexity. And the fact is, it's not going to get, any, less complex soon. Now, I want to finish on a high note, though, rather than a low note. And the high note here there are some really great open source projects that mask a lot of that complexity. So we have Janus, WebRTC server built in Napoli, and also Jitsi, which has excellent video conferencing with end-to-end encryption in there. So these projects make some of that complexity a lot better. Also, these aren't standards engineers. These are just open source geeks that want to get stuff working. And I really do focus on getting a lot of the WebRTC stuff working for people. So they're an important part of this overall ecosystem. So again, I don't want to depress you. I'm just being frank and sharing with you the reality of the world we're in. So what should I do? And these are 6 recommendations I've made to a range of companies, and sort of keeping them to the ones that I see pop up most commonly within Asia. So options you've got: you build your own WebRTC-like system. Go, not invented here, WebRTC, going to do my own thing. You can build your own using those nice those nice open source projects I mentioned, and build your own orchestration and management. You can use system integrators. They can, so essentially share their expertise with other companies and then build your app on top of that. You can use a CPaaS, just the raw SDK with no professional services, or you can partner with them. And that's the sort of more general day-to-day way of working with them. But I do mention the other because some of the big guys have basically just taken a very simplistic approach, in part because then they can dual source. Or you can use one of the few vertically integrated specialized solutions that fit your particular use case around real-time communications. So I'm going to run through each of these in terms of their pros and their cons. So let's start with the first, which is build your own WebRTC. Example, of course, is Zoom. Now, this is all speculation. I have no internal knowledge of what Zoom does, but speculation is it's WebAssembly they're using for their current implementation to download their codec, and it's native. Of course, it's basically C++ optimized code. Then they just do video communications, video conferencing on laptops and on mobile phones, and they can do a lot of optimization around the specific scenarios they need to work around screen sharing, how the different camera resolutions, some of the peculiarities of the different cameras. But most importantly, and this is I think what really differentiates their product in the market, a very tight feedback loop, so the encoder closely follows network conditions, because it does work. I know there's lots of Zoom haters out there, but I remain very impressed that their video just works. I mean, I've been working on video communications for 30 years. Yes, I've worked on PSTN video phones, ISDN video phones, and on some of the video sort of communications over the internet. And even then, because of the variability of the internet, we were looking at how we can link network performance to encoder performance. So that's even so long ago we were looking at those types of issues. I think that is one of the secret sauces that Zoom has. Now the pros: control. I mean, you're not beholden to Google in this game. Differentiated service experience, and it is good. Video call continues to work when I know others would have stalled, for sure. And I always remain amazed when I've been doing interviews with people in Asia, in India. It's Sunday morning my time, Sunday evening their time, and of course they're in a big apartment complex. Everybody's streaming on the internet, and we're still able to hold a video call. I mean, it's only a few years ago that that would be impossible. So again, very impressed with what they're able to do. You can deliver purpose-built experiences. You avoid the dependence on libWebRTC. Just to repeat again, libWebRTC is the de facto standard implementation for WebRTC compliant clients. It's behind Chrome, Firefox, Safari, Edge, 10-year-old C, C++ set of libraries. Basically, sort of Google owns it, and Google engineers keep messing about with it. Cons, it's rare expertise. You really are. There's a few hundred people in the world that can do this, and that's the reason Eric, brought his team out of Cisco to build Zoom. Some of the other WebEx engineers, went off and formed Agora.io. So it really is, it's rare skills, and that comes back to the endurance hunting issue I was raising. You may not be able to take advantage of the hardware acceleration because, again, Google has quite a span of control, from the hardware all the way through up into the browser. But again, there are ways around it, and once you've got the native app, you're fine. There is a significant maintenance burden, but this is the hardest piece, and this one I think you have to get right. It's a strong company culture on product discipline that is fighting feature creep and execution focus. One of the reasons why they did not implement end-to-end encryption, because their whole focus is user experience to make it as slick and easy, and it just damn well works. End-to-end encryption, it helps there, but there's a certain amount of teething you have to go through. So again, it was this execution focus. We've got to focus on the experience. Yes, we'll get there with end-to-end encryption because it's an important tick sheet for enterprise, but that's part of the sort of thinking, the culture, the ethos that drove them in that particular direction. Now, just want to say a couple of words around libWebRTC dependency. There are emerging personal projects like Python, based on Python and Go, some libraries that you can take advantage of. Tim Panton, and I just include a link to his tweet there, says the pipe stack now shares no code with the libWebRTC. So they've got something that's wholly independent. And now, they're more focused on sort of data, using the data channel. But again, I think we're going to see, because, of Google's control, because, a lot of open source geeks hate it when there's Google in control, we'll see, other options becoming available. Now, they'll be used in niche, applications. It won't be general applications, but you've got an existence proof. And as soon as you have an existence proof, that potentially has the way to create an alternative. So I just wanted to mention that because I do see that coming available. Right, let's look at option number 2. This is building your own using some of the open source projects. A good example here, and this popped up only a couple of weeks ago, was Simwood have just launched their conferencing app using Jitsi, and of course some customizations around it, as you would imagine. Now, Jitsi and Janus are both excellent open source projects with smart teams, and as I said, they're not standards engineers. These are open source engineers that just want to get stuff working. Now, Jitsi is a video conferencing with end-to-end encryption, and it's funded by 8x8. Now, it's far more than that. And in the open source landscape review, there you can get more information about all the cool stuff that they do. Janus is a general purpose WebRTC server that abstracts a lot of the complexity developed by Michio in Napoli. So you can leverage those projects and the teams to help you abstract some of that complexity. And also, there are lots of other open source projects around whiteboarding, recording, integration to the PSTN, PBX. Also, if you can be successful in building this out yourself, you then make your organization a target for M&A because of this rare skills. Now, on the cons, you have to build your own redundancy and scaling, which, if the services used internationally, can get complex fast. High availability for real-time communication services is not the same as web high availability. So, again, you've got rare skills. You're very dependent on your relationship with the Janet and Gypsy teams, but they're friendly guys. But if you start banging heads with 8x8 and you become a threat, you might find that you have a need that, the open source project may not be fulfilling as quickly as you would like. So you might need the ability to fork the project. That is, you go, okay, it's getting too hard, and you take the code and you run in your own direction. But that then means you've got a lot of skills, and you need to have a lot of skills, a very good team to be able to do that. Also, you need a product culture and specific expertise on real-time end-to-end communications, both from product management and UI, UX. These are rare skills. This is part of the advantage of using a CPaaS partner, because they bring a lot of that experience to you. Still dependent on WebRTC, even in this case, so you need to be tracking Chrome and the librtc bugs and all the features that they keep adding in, which is still a rare skill. And you've got a dependency on the open source projects, because a problem or sort of bug might crop up and it's critical for you, while for the open source project it's there on their roadmap, but maybe not as fast as you need it. Now the great thing is you can build a patch and then contribute it back to the project. But again, that might be revealing certain details that you might be concerned about. But again, that's part of the advantage of open source, is the community helps itself. Now, system integrators. So this Opus, remember, they were at the workshop back in 2013. They were showing their coffee sip, and because I invited them in to do their demo, they were very grateful, and they gave me this little present here from. It's a piece of art from their. It's famous in their sort of region. I just wanted to show, this is a picture from a couple of days ago of it on my kitchen table. So you can see, I still have the present they gave me. But back to the presentation. The pros, the integrator manages and tracks the open source projects, the librtc, and the browser issues. WebRTC now can be, that complexity can be hidden behind an SDK. Integrator can have a whole host of ready-made components and building blocks. So it helps you get to market faster. With Opus, Oracle, for example, has used them for many, many years. On the cons, scaling is reduced, but you still need a DevOps team and high availability expertise. You still need that product culture and specific expertise on real-time end-to-end communications, product management, and the UI, UX. Can't understate that. You've got dependency now on the integrator, and they've got rare skills, so they're an M&A target. Again, back to this acquihire and endurance hunting. And also, you're limited to an extent by the integrator's feature set and roadmap. But if you throw enough money at them, I'm sure they'll do what you ask. So that's the third option. Looking at the fourth. So this is CPaaS, but really just using them hands off. The example I give here is Uber. It uses multiple CPaaS providers. And it's very much, it's got its spec. Here's what I need. Make this happen for me. Thank you and goodbye. The advantage now is the CPaaS is responsible for all the working around the bugs, keeping compatibility between the browsers and WebRTC versions. So WebRTC and some of its complexity are now hidden behind the SDK. Also, they provide tons of additional services. So call recording, integration with other services, also compliance. So, like HIPAA compliance, which is very important for certain verticals. Also, you can rely on the CPaaS provider for providing you with the redundancy, scaling, all that good stuff. And as I mentioned, I used Uber simply because, you can dual source, because CPaaS providers keep getting bought. I mean, even Twilio, given its size, there's still, one day Amazon might decide, you know what, it's easy to just buy them. On the cons, cost of using the CPaaS, because they're providing a lot of services. You've now got a dependency on them, as I mentioned, as M&A there. You still need this product culture with specific expertise. on real-time end-to-end communications, tight product management, and the whole UI UX around it. And of course, always the battle in prioritizing your needs with the larger CPaaS customer base. And then this one is the more sort of typical CPaaS use case. So this is, the customers of Twilio, Nexmo, VoIP Innovations, Appiday, Simward, all those CPaaS providers. Again, the pros, they're managing that WebRTC complexity. It's hidden behind an SDK. They provide lots of additional services. They're doing all this, scaling, redundancy, certifications. You can still, if you work hard at this, dual source. It's a lot harder when you've got a partner, but it's still possible. And this is a significant benefit I see in a lot of projects, is the partner can help you around this gap in specific expertise on sort of real-time communications, what the UI UX should look like, how to manage the product. So there's a lot of sort of additional advantages beyond just the API from a CPaaS provider. On the cons, the cost, because they're doing a lot. Dependency on the team. You still need to have some, sort of expertise. You've got the balance between your needs, their needs. You now have a very strong dependency on this partner. As I said, they might get bought up, and they could always do a Twilio on you. That is, they become a global competitor, like TalkDesk. TalkDesk was a major company, a major partner of Twilio. They were running all their traffic through Twilio, and then within one Enterprise Connect event, they announced that, well, we now do Flex, which is 95% of a contact center as a service solution. So all of a sudden, TalkDesk found it had a major competitor. And then the final one. You could use one of the few vertically integrated specialized solutions that fit your use case. So like the Zoom SDK or GoToMeeting API. So it's a ready-to-use service for conferencing, video calling, whatever. You can focus on the total experience, because the video or the communications could be a small piece of your overall offer. There's a whole host of business workflow stuff and other integrations. It removes the need for the rest skills. So, cons, of course, it's, you need to have significant value in your vertical. The RTC service is a smaller piece of the overall value proposition. Your business proposition needs to be strong enough to be able to cope with what will be the expense on per cost, sort of per session, per minute, but it removes all the other risks and costs. So hopefully that gives you a feel for the 6 options. And to quote a great man, is WebRTC the right choice for my RTC project? It depends. But hopefully I've given you 6 degrees of freedom that I see and the pros and cons associated with each. So here's the link to the weblog that this is going to be published under. You can also contact me directly if you have any questions, queries. But I hope that in sort of being very frank and to the point around where WebRTC is, where it's going, and then these 6 sort of options, it really moves a lot of companies from, oh, this seems a little bit complex, let's wait, to actually being taking action in this space. So again, thank you so much for taking the time. Again, if you've got any questions, please ask. Thank you.